All right, we're going to be talking about a new type of hypothesis test today, and it's called a match pairs t-test. So the basic setup is up there. You've got a bunch of students who want to see if sex sells in advertising. So they arrange the setup where they get 10 similar items and et cetera, et cetera. You can read for yourself here. But basically at the end of it, it says, is there evidence that sex sells in advertising? So they've got their 12 subjects over here. And this is how many ads each subject remembers out of 10. So this would be 5 out of 10 had a sexual image that this person remembered, and this is only 4 out of 10, but that did not have a sexual image inside the advertising. So the problem is that we don't have two samples that are independent because it's the same person measured twice. So the workaround on this is going to be looking at the difference between the samples. So in other words, we're going to take the number that there was remembered that a sexual image and subtract out the number that did not. So if I go 5 minus 4, that would be 1. So that'd be 1 more. That would be 3 more, 0 more, et cetera, down the list. So you can just go ahead and write in all the numbers. That's -1, +2, et cetera. So I'm going to go ahead and do that here. It'd be a 2, a 1, and a 0. So we're going to end up using those differences here in our match pairs t-test. So let's go ahead now and write our hypotheses. Our null hypothesis would be that the mean of those differences is 0, so that there would be no difference between the two types of ads. And then the alternate would be the mean of the differences is greater than 0. And we're saying greater than 0 because we're trying to see if sex really does sell, so they ought to remember more ads that have a sexual image than those who do not. Let's also define mu in this case, so that would be ads remembered. And then we also need to say as well which difference did we do, and we did the sexual type versus the non-sexual type. So we're going to write sexual minus none. So those are your hypotheses. Moving on to our conditions. We've got potentially 5 here. Some of these are going to look familiar, some are going to be new. The first one definitely is new, and we're talking about pairing our data, and we're doing that because each person has 2 scores. So it makes sense in this case to do that. The differences in those scores between each person are going to be independent. So what that means is, coming back here, is this difference of 1 does not impact that difference of 3 or that difference of 0. Every person's a different person and remembers things differently, so the differences actually are independent, although the samples originally are not. Check. The ads were randomly ordered in the experiment, so that takes care of our randomization part. And then finally, we look at the histogram of the differences. So remember, we're looking at the differences, so it's important to say that when we write out our conditions, and that they were approximately normal when I did my TA84 graphing calculator, and this is what I came up with. And this is a match pairs t-test is what this is called. Also note, if this was not an experiment, and obviously it was, if it was sampling, we'd want to talk about the 10% condition, but obviously we're doing an experiment, so we won't. All right, let's go on to the actual mechanics here of the test, all the numbers here. So when I put the differences in my calculator, the mean of those differences was 0.917. My standard deviation of those differences is 1.24. N was 12, degrees of freedom is 1 less 11. So this is going to look a lot like a one sample t-test. I'm going to go ahead and I'm going to draw my t-curve in here, and that is a t11 curve. It's going to have a mu of 0 because that comes from my null hypothesis. My difference was 0.917, and I'm going to shade to the right of that. Let's go ahead and calculate the standard error. That would be the standard deviation divided by the square root of 12. And that ends up being about 0.358. So that's the variability I'm going to be using in my t-curve here. Then I'm going to go ahead and calculate the t-score. So that would be 0.917 minus 0 divided by 0.358. And on my calculator, I just got 2.561. And then let's calculate our p-value. And our p-value would be the probability that t11 is greater than 2.561. And using tcdf on my calculator, I got 0.013. And of course, as we know, if it's below 5% like it is, we're going to end up rejecting the null hypothesis. So let's write that out. We reject the null hypothesis since our p-value is less than 5%. There is strong evidence that sex does indeed sell in advertising. All right, let's move on to the confidence interval and wrap this bad boy up. Basically, it's the mean of our differences. We've got our standard error, so that's going to be involved in the formula here. T star 11 is going to be 1.796. 0.917 plus or minus, let's get our margin of error by multiplying these two numbers together. So our margin of error ends up being about 0.643. And if I go ahead and add those two together and subtract them, I wind up on the low end of 0.274 and on the high end of about 1.560. So in our final statement here, we are going to say we are 90% confident. And remember, we're using 90% confidence because this is a one-tailed confidence, one-tailed hypothesis test. And we're confident that, and this is about a difference in how you remember, so that people will remember, and it's about that many more. So 0.274 to 1.56 more ads, and that's out of 10, with sexual content than those without. So there you have it. That's our confidence interval and our hypothesis test for matched pairs.